All right, so while we are waiting for people to come, the question is 5 with a pound sign equals 30. What is the pound sign mathematically? So have you ever seen anything structurally like this before?
No, I don't think so.
You've never seen any, I'm sorry?
Just like a symbol after a number?
Yeah, like a punctuation mark after a number.
Factorial.
Factorials.
Yeah.
So what would 5 factorial be?
120.
120. So now that you know 5 factorial is 120, what might you guess the pound sign is?
Factorial over 4.
Okay, so factorial over 4 would work here, but it is extremely unlikely we would introduce a symbol to be factorial over 4. So while we were waiting for people, there was a discussion as to whether or not you had 30 or 32 hours for the take-home exam. And I said 30 because 30 is a much better number than 32. 32 is merely a power of 2, whereas 30 is 5 pound sign. And so the question we're trying to figure out is, can you deduce what pound sign is in mathematics? So I had asked, does anybody know anything else where you have a number followed by a punctuation mark? And factorial was suggesting, 5 factorial is 120. One suggestion is maybe the pound sign means take the factorial and divide by 4, but it is unlikely we would just do a divide by 4.
Multiply by 1 plus 5 times 6.
I'm sorry? Okay, so one possibility, and that's not a terrible one, is that it takes the number and multiplies by the next number after it. It's not horrible, but it's not great. So the hint is that we've got the factorial on the board.
Skip one number in the factorial. So like n factorial over n minus 1.
Possible.
Yeah, but that wouldn't make 30, would it?
It would also be a waste of a symbol.
It doesn't seem like it's the greatest use of a symbol. I want to introduce a symbol for things that will be used for many things. Now, if you go back, does anybody remember what 5 factorial is?
Every other.
It's every other. So it's 5 times 3 times 1. It does not equal the factorial of 5 factorial. And the reason is the factorial of the factorial doesn't really occur that often in mathematics. But products where you have every other occurs all the time. So, again, let's do an example. Let's say we have the numbers 1, 2, 3, 4, 2n minus 1, 2n. So we have 2n objects. And we want to match the objects in pairs. How many ways are there to match in pairs? This is not what I thought we would be doing today, but...
2 and choose 2.
Okay, why 2 and choose 2?
Because there's 2 n objects, and that's the number of ways to choose 2 of them.
But that only matches 2 objects together. I want everything to be paired together.
Oh.
So you're on the right track.
What's the distinction?
So 2 and choose 2 is how many ways you can choose 2 objects to be paired. I want to have everybody paired off with exactly one other person. So there are 6 of us here. Right? We can pair people by closest birthday. Hopefully that's enough so that we don't have 2 people that could be pulled in different ways.
Wait, so it's not how many ways to pair, but how many sets of pairs you can?
No, I want how many ways are there to pair so that everybody is in exactly one pair. So for instance, I could do the simple pair 1 with 2, 3 with 4, 2n with 2n minus 1.
Right.
Or I could do 1 with 3, 2 with 4. So everybody must be chosen once and only once. And you must be in a pair with 2. So 2 and choose 2 is how many ways to choose 2 people to be together.
So, we can define it recursively from here, right?
Yep.
2n equals 2n choose 2 times t, so 2n equals 2. Right?
Okay, so you want to now get a recursion relation.
Yeah.
T2n is 2n choose 2, T2n minus 2.
Yeah.
And you might even just do, maybe, we'll call it un is 2n choose 2, un minus 1, just to make the symbols and the notation a bit nicer. If we were to continue with your idea here, there's two ways to choose the first pair. How many ways can I choose the next pair?
2n minus 2, choose 2.
Right? And then 2n minus 4, choose 2, all the way down to 2, choose 2.
Yeah.
So is this the number of ways to pair in groups of 2? I have 2n choose 2 ways to choose my first pair. I have 2n minus 1 choose 2 ways to choose my second pair.
Seems right.
Seems right. It's not, but it seems right. There's a very subtle issue here. If I had a better voice today, I could try it. I'll try. There are 2n minus 2 ways to choose the first pair. And then there are 2n minus 2 ways to choose the second pair.
It's ordered.
This is now ordered.
So we need to divide by.
So what do we divide by? Because we've got first pair, second pair, third pair. So how many pairs are there?
N.
So what do we divide by?
And
N factorial. So we're only off by one symbol, but it's a quite large symbol. Now if you want to see what this is, if you actually do out the algebra, this is 2n times 2n minus 1 over 2, 2n minus 2 times 2n minus 3 over 2, 2n minus 4 times 2n minus 5 over 2. So the numerator is just going to be 2n factorial divided by 2 to the n divided by n factorial. Oh, well, if I put the 2 to the n downstairs, then this becomes all the even numbers. And I'm left with 2n minus 1, 2n minus 3, all the way down to 1. So the number of ways to match everybody in a pair is 2n minus 1 double factorial. It turns out these are the moments of the Gaussian, the standard normal. So there's a lot of combinatorial significance to the moments of the normal. We can calculate this directly. I like the idea of using recursion. So the question is this the right way to go for the recursion?
Don't you have to divide by.
Yes, so this is the problem, is we saw over here that this is the number of ways to have ordered pairs. So one possibility would be we would have to have maybe symbols for the ordered and the unordered. Do the unordered here, and then divide by n factorial. This is somewhat similar to when we analyzed the Catalan numbers. We looked at how many ways were there to say below the main diagonal, and then how many ways where you first hit the main diagonal at a certain point, and we partitioned along those lines. So over here, the question is this going to be exactly what we want? Yes?
Why can't you just do, for the recursion, like what we have divided by n?
This divided by n?
Yeah.
So I'm not sure if it's that divided by n. I get something.
Well, but so for the explicit, if you had, to the n
Oh,
minus
wait.
1 case.
No, but it'll be correct. It'll be correct if you divide by n.
You want to divide by n times n minus 1. Right?
Yes. So if you divide this by n, it will be correct.
Wouldn't it be?
So here's one way to look at it. Let's let an be the number of ways.
It's not n minus 1 if you're not actually missing any.
So it'll be the number of ways to match 2n objects in pairs. choose a special number from 1 to 2n. What's your special number? There's two natural choices. N? Not n. So when you look at this list, two numbers are special.
2n minus 1.
Nope, but you're close. 2n. It's the end. This number must be matched with somebody. How many ways are there to choose who you match 2n with?
2 minus 1.
2n minus 1. So A of n is going to be 2n minus 1. And now we match this with somebody. And now we have 2n minus 2 elements. So we get this as the recursion. And now you can see the double factorial coming into play.
What made you realize that you wanted to do that though?
20 years experience as a card-carrying member of the American Math Society. No, and just the more times you look at this, the real problem, any time you have a combinatorial problem, is double counting.
Yeah.
It is so easy to double count, and you always want to ask yourself, have I added order? Have I added extra structure? And the analysis we were doing initially, we implicitly were making an order. We said, this is the first pair. You then have to remember to remove the extra pair. So over here, there's two ways to choose two objects to be a pair. But now that's a special pair. We gave that pair a label. It could have actually had n labels. So dividing by n, I think, is actually justified. So I think if you then just said this divided by n, you then get exactly the same as this, because you'll get 2n minus 1 over 2n. And if you realize you've given this the label 1, it could have had any of n labels, now you can justify dividing by n. So this explains the double factorial notation. I can't say anything, but if you want to, that's absolutely fine with me.
I'm just how long is it going to take you to figure this out?
We can actually check, because this is being recorded, and we can see.
It's just
This is a new rapid. Probably. They used to be made of paper, so you could just tear them.
yeah.
Now
Right.
they're plastic.
I mean, whatever. Wow. Continue.
Yes, yeah. But the whole point is to try to understand why we use the notation we use, why we study what we study. The double factorial is useful. The factorial of the factorial typically is not. Any computer science people here? What base do you do logarithms in?
2.
2. Why?
Because usually you like to split problems into halves when you have an algorithm, and then
Great.
if you do that as many times as you can, that's log.
Great. So there's a lot of the divide and conquer, binary search, the splitting things up. And so log 2 is a natural base. Thank you. One person at least got the joke.
Yeah, I just didn't.
Didn't think it was funny. All right.
No.
So at least for computer science, you can also defend 2 by you do things in binary. In analytic number theory, the log 2 of x actually means the log of the log of x. And the log 3 of x means the log of the log of the log of x. Just because in some problems you have such small discernments in terms of behavior, where you're really trying to save powers and powers and powers, or logs of logs of logs, these things actually come up. And so this becomes the notation for the iterated logarithm. And you just have to be careful. In fact, the paper I'm reading right now is very good. It says quite clearly in the beginning, note, by log 3 of x, we mean log of log of log of x. It's nice that they have a log 3, because there's no reason you would ever be working base 3 in a number theory paper. So you know it's got to be this one over here. We still haven't answered what this number means, what that symbol means. Any thoughts as to what 5 sharp or pound sign?
I don't know. You just said sharp, so now it makes me think about something like.
Is it a sharp or is it a pound sign? It's the pound sign, right?
Pound sign, or sometimes say hashtag, but
Hashtag
pound sign.
Pound.
pound
I
sign.
say pound sign.
And I go with hashtag.
I'm saying, but how long has the phrase hashtag been in existence? Because this goes back well before.
No, the pound was before because of the phone.
Yeah.
Yeah.
My brother actually knows the person who came up with.
The at sign?
Yes.
Really?
Yes. It's his idea. Any thoughts as to what the pound sign might mean? How can we get 30 from 5? And what do you think it should be?
Multiply is it the product of the numbers that you use as sum? No.
But you're close, and I think you might have just inspired somebody. Someone is on the
The
cusp.
product of all primes that are less than that number?
Oh yeah, that's good.
It's 2, 3, 5.
The product of all primes less than.
Wasn't it all 2 and... Oh, you include 5, okay. You said less.
So if you so you said less than. If you do less than or equal to, you would get 30.
Wait, how did you think of that? You were just like, you thought
Well,
you
just-
liked primes.
Just 2, 3, 5. Yeah.
But what is the factorial?
Mhm.
The factorial is the product of all numbers up to 5,
natural numbers.
and we get 120. So how are we getting 30? Now what's nice is if you try to do like the prime factorization of 30, if you try to do the factor tree, 6 times 5, 2 times 3, right? If you do the factor tree, it's screaming at you the right definition. So 7 primorial would be 7 times 5 primorial, or 210. And so this is called the primorial.
Is this a common notation used?
Yes. So there are a lot of problems where what matters is just the product of the primes up to a point. And the advantage of the primorial symbol is it's similar to the factorial symbol, so you should be thinking about that. One of the things people often look at is you could have races to see what's the most popular distance between primes. Or you could have the most popular distance between consecutive primes. What do you think happens to the most popular distance between primes as you go further and further down the number line? Yes, you get bigger and bigger. The average spacing between primes of height x is log x. So it can't stay constant because the average spacing is going up and up and up. Well, maybe it could, but you'd have to have some really strange behavior where you have a huge number of small gaps being balanced by much larger gaps. So the average spacing between primes grows. And if you ask, what's your champion gap? Which gap is more popular than the others?
I thought we talked about it. It's like, isn't it 2 times the prime?
Well, it's going to be 2 times something because there's only one even prime. So that's the only one that's going to generate odd gaps. All the other gaps are going to be even numbers. And so it's the primorials that come into play in determining who wins. So the primorials are related to, they sometimes call these the jumping champions. All right, so this was a interlude while we were waiting for people to come to class today in terms of 32 versus 30 hours for the exam.
Why not just give us 7 primorial hours?
Wow.
So,
Do you really want to take an exam?
so that's the concern. The concern is that if you have too many hours for the exam, you will feel compelled to spend the hours on the exam. No, because you'll be like, I could do more. And so it's actually in your own benefit to have the exam time limited. And then why is it 6 hours for sleep?
You generally want us to sleep.
Well, I do want you to sleep. There are a lot of students who will stay up 24 hours working on an exam, thinking it's much better to keep working than to actually get some rest and have the ability to think logically, reasonably. But why 6?
3 primorial.
Oh, okay, I was going to say 3 factorial. So then this leads to an interesting question. 3 primorial equals 3 factorial. Are there any other numbers where this holds?
2.
Yes. 2 primorial equals 2 factorial. any other numbers.
There shouldn't be.
There shouldn't be. Why not?
Because
They're running a different.
you have to multiply by 4 in the factorial, and there's no 4 in the primordial.
Right. Once we get to 5 primordial, we've lost the factor 4. And so the factorial is clearly greater than or equal to the primordial. Let me see if I can do this problem from head, or if you want, I can quickly look it up.
You said the primordial is greater than or equal to the.
I'm sorry, the factorial is greater
Okay,
than
cool.
sorry,
That works.
Is primordial for 1 under definition?
So, for a lot of these things, it's not always clear what the definition is in those cases.
Well,
Yeah.
it's not primes. Couldn't it just
What's the
what would
base
it be?
multiplier?
Right.
Is it 1?
That's interesting.
So, I would probably define 1 primordial to be 1.
So then factorial does equal 1 primordial.
Um,
Same with 0 primordial.
So here, actually, I've got Mathematica open up.
You'd say it's
Base value
1?
is 1.
Yeah.
It's the same thing for factorial.
Nope. So Mathematica did not like 5 with the pound sign after it. So we frequently define the empty product to be 1. And so over here on Wikipedia, source of all wisdom, fountain of all knowledge, it says 1 primordial is 1.
Is it the same for 0 primordial?
And it says 0 primordial is also 1. So it starts off 1, 1, 2, so it kind of looks like the Fibonacci's. And then it defines 4 primordial to be 6. So it's the product of all primes less than or equal to your number. So you can still at least define. So what if I wanted to solve x factorial plus y factorial equals z factorial? X, y, z equals 0 integers. So stuff like this was a green chicken problem years ago. Are there any solutions? Okay, give me a solution.
0, 0, 2.
0, 0,
2.
2. Any other solutions?
0,
Kind
1,
of
2.
boring, but.
0, 1, 2. Any other solutions?
1, 0, 2.
Okay, so let's assume x less equal to y less equal to z, so we can at least exclude the 1, 0.
1, 1.
Sorry?
1, 1.
So we do have 1 plus 1 equals 2.
Wait, why can't you still do 0, 1, 2?
I'm sorry?
You can't, you just can't do 1, 0.
I don't, right. So without loss of generality, I might as well assume x is less than equal to y less than equal to z. If you wanted to, could you have x less than equal to z less than equal to y? Not with the letters written like this. So we know z has to be greater than equal to y, z has to be greater than equal to x. Without loss of generality, let's just make x the smaller. So do you think there are any other solutions? I mean, we at least got 3 solutions.
I thought so. Maybe not.
Well, 1, 2, 3.
Well, we know that x factorial evenly divides y factorial.
Why?
Since if y is greater than or equal to x,
Yes.
then it's y times y minus 1 times dot 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 times.
Good. So x factorial divides y factorial.
Well,
Yes.
Can't you also say that the greatest of the sum on the left-hand side is going to be 2y factorial?
Yes. So left-hand side is at most 2 times y factorial. And so if z is strictly greater than y, you're in trouble if y is greater than or equal to 2. Because if y is at least 2, then you've got to have at least a factor of 3 on this side over here. So as soon as you have that observation, we now know y is at most 1. And now we can handle those cases by brute force. So as long as we're here, try to pull up some green chicken exams.
This looks like Middlebury, right?
Yes. I think maybe it was the 2010 problem. Oh, no, it was the 2008. Okay, yes. So, right, so this was one of the problems in the green chicken in 2010. All right. So, let's do one more, and then we're going to stop a little bit early today because I'm not feeling well. But there was a problem I posed a long time ago which we haven't solved. And this is the magic wand of death. So, and I think I sent some clips from the movie Tron where you have the rings and whatnot. So when you take your magic wand and you tap the complex plane, it kills everything that's not a rational distance from the origin. So tap kills all x, y that are not a rational distance from the tap. Those survive. So in one tap, if you want, without loss of generality, where's your first tap?
0, 0.
Yeah, you might as well make it 0, 0, 0. So the only thing that survives after one tap is circles with rational radii. So my first question is, can I kill the entire plane with infinitely many taps? If yes, can I do it with finitely many taps? And if yes, what's that finite number? So you think it's 3?
I think it's 3, yeah.
Okay. Anybody else have any other numbers? Can you do it with an explicit 3, or is this there must be 3?
I think I was supposed to.
Okay. So how do you do it?
I think 0, 0, 0, 1.
Okay, good. So without loss of generality, your first tap is at 0, 0. Without loss of generality, where's your second tap?
I went 0, 1.
Sorry?
It's not without loss of generality.
So that's my question is, can you do it without loss of generality, or is there now, it makes a difference? It does make a difference. You can't quite rescale. You can rescale by rational amounts.
I tap at another.
So 0, 0, 1, 0, and what else?
Then it's 0, 1, right?
Oh, you did 0, 1?
Well, what
That's
you
0.
marked.
Oh, sorry. Sorry.
And then I tap at 0, root 2.
Okay.
Or root 2, 0, whatever you want.
The fact that I'm still standing is impressive. Okay. So how did you go about this?
So I said a squared plus b squared.
Okay, so you're doing the
Or x,
okay.
sorry.
Oh.
Was it for any point line? So for any point that survives this,
Right.
we know that x squared plus y squared equals, yeah.
Okay.
Wait, I lost my math. And then x squared plus y minus 1 squared equals,
cube.
yeah.
And then x minus root 2 squared plus y squared is in
So
the cube.
what I did is I said x squared plus y squared equals a over b for
Okay.
some integers a and b,
Okay.
and then same thing with x squared. And
Well, I would say from this you immediately deduce that 2y is rational.
well, yes, that was. Oh yeah, that's a lot faster.
Right. Because when you expand this out, you get x squared plus y squared plus 1 plus minus 2xy. Has to be
just 2y.
I'm sorry?
Minus 2y.
I'm sorry, minus 2y. Minus 2y is rational. We know x squared plus y squared is rational. So we get that 2y has to be rational. So we get y is rational. So these two immediately force y to be rational. So all you need to do is choose another tap that's going to force y to be irrational. Do we know anything about x at this point? Just using these two taps.
Oh, well, it must be rational.
So now that we know, well,
Oh no.
so we know y squared is rational. So we know x squared is rational. Right? So I'm trying to think when I solved this, I can't remember if I did root 2 or if I took like something with a cube root or something. But okay, so when you expand this out, you'll now get x squared minus 2 root 2x plus 2 plus y squared is in Q. And then if I take the x squared with this stuff over here, we know x squared plus y squared is rational. So we get negative 2 root 2x is rational.
I think I tapped at 0 root 2.
Oh, so you did three things on the...
Yeah,
Okay.
they were all.
Okay.
I just ignored x.
But this is actually a good way to go because you've already got y's in rational.
Yeah.
So if you keep tapping like this, the hope is that you can then force. So now you would get x squared plus y minus square root of 2 squared is rational. So x squared plus y squared plus 2, that's all rational. Then you get a minus 2 root 2y is rational. So root 2y is rational. Therefore, root 2 is rational. Contradiction. All right. So I'm going to end class with the following challenge. Choose 3 points uniformly at random in the complex plane. Okay, we can't do that. But let's imagine we could. So you could take maybe ever-enlarging circles. You take a circle of radius r, choose 3 points uniformly at random. What's the probability that if you tap at those 3 points, you kill everything? So what I'm saying is over here, this was constructive. Right? We constructed a way to do with 3. And in fact, you can show that you can't do it with just 2, because if I give you any 2 points, if I choose a radius that's bigger than their distance, or even take their distance, well, no, take an integer that's bigger than the distance between them, and just draw your circles like that. They'll intersect. And then we'll prove to you that 2 taps can never kill everything. What do you think the probability is if I choose 3 points at random that if I tap there, everything is killed? What do you think? What should the probability be between? Should be, as long as the probability exists, it should be between 0 and 1. It may not exist. Now the other thing is, if I have 3 points, I can rescale all of them if I want by dividing by a large rational number. So it may not be unreasonable to say, choose 3 points in the unit circle. You might be able to make an argument that you can always choose your 3 taps to be in the unit circle. What's the probability that you will kill everything? What do you think it would be? So if I give you 3 points.
Can you have probability distributions over like an uncountably large space?
Yes, as long as it's not uniform. I can't have a uniform distribution on an uncountably large space.
Right,
That's
I
why I'm
thought
saying
you said it-
restrict it to the unit disk. Because if I have 3 points that are very far out, if I multiply all the coordinates of the points by,
I thought the unit disk still has uncountably many
right, oh wait a minute.
points on it.
Oh no, it's the distances from those points. If I just scale them inward, that could be changing where things are. So let's just keep it to, I choose 3 points in the unit disk. What's the probability of everything? No, if I rescale all the points by a rational number, I'm just going to rescale the distances by a rational number. Yeah, so I can scale everything down to be in the unit disk. Because if I give you any 3 points in the complex plane, just rescale all of them by dividing all their coordinates by 10 to the billion. So I'm just shrinking the whole complex plane. Yes?
I would think it would approach 1.
It should probably approach 1. So the question is whether or not you can actually show this. So what class do you think this might belong to?
Complex analysis.
Not complex. Measure theory. You know, what's the measure of the set of all points? That basically any 3 generic points should do it. But it's often hard to find a specific set of 3 generic points. So I'll leave you with the following problem from linear algebra. Do you remember what it means for a set of vectors to be linearly independent? So if you have n vectors, the only linear combination of them, that is the 0 vector, is multiplying all of them by 0. So v1, vn live in Rn, and then you said they're linearly independent if a1 v1 plus an vn equals 0 implies a1 equals an equals 0. So that the only way the linear combination can be 0 is if each component is 0. I want to construct an n by infinity matrix such that any n columns are linearly independent. So that's your challenge. Construct an n by infinity matrix, or prove at least that one exists. So you don't answer. So
No,
just
a quick question.
yes.
Is n the height of a column?
So it's going to be, this direction will be n,
Okay.
and it will be infinitely long in this direction. And no matter what n columns you choose, you'll then get an n by n matrix, and it'll be linearly independent. So my question is that possible? This must be somehow connected to what we were just doing a moment ago, because this was not a pre-planned lecture. Right?
So if you choose any finite number greater than n,
Well, then it has to be linearly dependent.
then I think it works. So there exists a matrix of.
I'm not saying that the matrix is linearly independent. I'm not saying that the columns of the matrix are linearly independent. I'm saying whichever n columns you choose, each column has n entries. So you'll get n vectors that are n components. And that will give you an n by n submatrix. So maybe you choose B1, B4, B8, B17, B111, B9, and plus 8. And those will be your n vectors. Then that determinant will be 0. Or they'll be linearly independent, however you want to phrase it. But no matter which n vectors you choose, my matrix is such that the result will be linearly independent. Or prove that this can't be done. That there's no way to build such a matrix. Given that I'm tacking that on now, you probably have some idea of which one is the truth. And then 2 questions similar to before. Prove it can be done, and then if possible, Give me a matrix that works. So a lot of times you can just prove in mathematics, oh yeah, yes, it can be done. This is the mean value thing. There is a point where the slope at that point is equal to the average speed. Great, where's that point? Well, I can't quite tell you. We saw this in one of the dot games. We proved player one has a winning strategy. I can't tell you how to play. So the question is this one of those where, again, almost anything you write down will work? But in terms of actually being able to give me something explicit, is that possible? Over here, what we saw earlier, it wasn't that bad. 0, 0, 0, 1, 0 root 2. That's nice. That's explicit. That's clean. That's great. Is there something similar here? All right, so this is a good place to stop.